Howdy students, this is going to be the last video that's going to cover intermolecular forces, or what we call the attractions between forces. The first two are going to fall underneath an umbrella called the van der Waals forces. And these are going to be the weakest out of the four that we cover here. And the two that we're going to cover underneath van der Waals are London dispersion forces and dipole-dipole. So the first intermolecular force, which is the force between molecules, are going to be between nonpolar molecules. So if we have nonpolar molecules like H2, N2, O2, then we're going to be having London dispersion forces. Let's look at the picture down here. London dispersion, nonpolar molecules have equal sharing of electrons. But every now and then when they run into each other, they displace briefly their electrons, so that for just a little bit we get a partial positive and a partial negative charge. And when that happens, we get very small interactions between these molecules, which we call London dispersion forces. The second attraction that falls underneath van der Waals forces would be dipole-dipole interactions. These are going to be between polar molecules, and remember that polar is caused by a difference in electronegativity. So we take a look at the picture here. We're going to have a molecule like HF, where the sharing of electrons is unequal. We have a dipole moment, which has a partially positive and a partially negative charge. And because of that, we're going to have electrostatic attractions between molecules, which we call dipole interactions, or dipole-dipole. And so when two of these get around each other, one that has a positive and one that has a partial negative, we have an attraction, like a magnet. The third attraction is also a dipole interaction, except that it has specific elements that we need to look for. So this is the third intermolecular force. This is when we have a hydrogen that gets near nitrogen, oxygen, or fluorine. And if we rearrange it, it would spell out the word FON. So we have water molecules down here. This is a polar molecule because of the lone pairs. Oxygen's also more electronegative than both of the hydrogens. And so what we have is an interaction with another water molecule where the partial negative is attracted to the partial positive. Same as dipole-dipole, except that it's a stronger attraction because the difference in electronegativity is so great. This is what gives water properties like high surface tension and high specific heat capacity. And the last intermolecular force is ionic bonding, which occurs between metals and nonmetals. Electrons are transferred, and they are the strongest bond. So what I have my students draw are ions that are interlocking, like Na plus and Cl minus, and it would come together with another Na plus and Cl minus. And the intermolecular forces occur between the molecules. So if we rank them in order of strength, London dispersion is the weakest. Ionic bonds are the strongest. Ionic bonds are with ionic compounds. Hydrogen bonds and dipole-dipole we get with polar molecules, and London dispersion we get from nonpolar molecules.